Hi guys, and welcome to another video. In today's video lesson, we're going to be looking at grade 10 maths algebra, solving exponential equations. Now, if you haven't looked at the laws of exponents already, look at the previous videos that I've dealt with solving or simplifying exponents, because we need to know those laws of exponents before we can solve exponential equations. But I'll cover them as we go on. The first question that we're going to be looking at is from the DBE November 2018 paper 1 and question 2.1.3, which says if I have half to the 3x plus 1 equals to 32 and I'm solve for x, that's my instruction there, solve for x. The first thing that we need to be able to look at is the types of examples, right? So these I classify as type 1 examples. Type 1 examples is where factorization is not required, where we're removing a highest common factor. I will deal with that a little bit later. But let's look at the laws of exponents that I'm going to use here. For example, I'm going to be looking at the following. Half. How can I represent half with a prime base? Now remember that your prime bases are 2, 3, 5, 7, 11, and so on, right? The smallest prime number is 2, and then we move on. So half can be written as 2 to the minus 1. 32 can be written as 2 to the power 5. Okay, and if you look at that now, see I got 2 and 2 as my prime base. The thing about exponential equations is that your goal and your aim is to get a common base on both sides of the equation. Both sides of the equation. Now, as you can see, we can achieve that by doing that. We can write 2 to the minus 1 to the 3x plus 1 equals to 2 to the power 5. Okay, so we've done that first part there. Now we're going to open out this bracket. Now remember this law here, right? X to the m raised to the power n is equal to, when you got an index or exponent raised to a power, you have to multiply x to the m times n. So I'm going to do exactly that now. So it's going to be 2 to the minus 3x there, minus 1 times 3x is minus 3x, minus times plus 1 is minus 1 equals to 2 to the power 5. So what can you see now? You got a common base on both sides of the equation. So now once you've got the common base on both sides of the equation, now the bases fall away and you can equate the exponents. So now we can say that the bases fall away, therefore equate your exponents or your indices. So you got minus 3x minus 1 equals to 5. And now you're just going to solve for x. So minus 3x equals 2. If I take minus 1 to the other side, it will be plus 1. 5 plus 1 is 6. Divide both sides by the coefficient of x, which is negative 3. If I divide both sides by negative 3, I'll get x equals 2. So minus 3x over minus 3 is x, and 6 over minus 3 is minus 2. Therefore, x equals to minus 2. Let's go check out another example. So the next example that I'm looking at is from the November 2019 paper 1 there as well. Okay, these are all paper 1 questions. And if you look at it here, I got 2 to the x over 3 equals to 1 over 128. So it's more of the same thing here, right? So here you got 2 to the x over 3 equals to, now 128, right? How can we represent 128 as a prime base? So now that would be, let's check if we can use our calculator. Now some of the calculators have a fact button on it here. So you'll press like 128 equals to shift and fact. Unfortunately, my one doesn't have a fact button. Nevertheless, we can do it by trial and error. Let's say 2 to the 6. What's 2 to the 6? Oh, let's do that again. 2 to the 6 equals to, see, 64. So now let's go and check now if we can. See, get closer now. 2 to the 7. See, 128. So therefore, we know now that 128 is equals to 2 to the 7. All right, so it'll be 1 over 2 to the 7. Now, remember this rule here. If I have 1 over x, then I can represent it as x to the minus 1. Okay, because remember our aim here is to get a common base on both sides of the equal to sign. So we're going to say 2 to the x over 3 equals to 2 to the minus 7. Now once you have a common base on both sides of the equation, the bases fall away, and now you just equate the exponents. So x over 3 equals to minus 7. Now we're going to cross multiply here. Remember, x over 3 equals to minus 7 over 1. Cross multiply, x times 1 is x. 3 times negative 7 is negative 21. And that is my solution. So that is solving simple exponential equations. Learners, if you haven't subscribed already, subscribe to JL Maths. You can check out all my videos in order of the work schedule on jlmaths.com. Like my Facebook page, Justin Lazarus Mathematics, and I'll catch you in the next video.